Hello there, college algebra students. This video covers graphing lines. So at the top here, you can see that I've typed up what a linear equation is. The graph of a linear equation is a line, and a linear equation has one or two variables, and we can't have a variable raised to a power other than one to make it a linear equation. So let me give you a couple of examples of linear equations. You could have something like 2x plus 5y equals 8. That would be an example of a linear equation. You can have something like y equals negative 1/2 x minus 6. That would be a linear equation. You can have just one variable, y equals 10. And so if we were to graph these equations, it would be a line. Examples of equations that are not linear, something like y equals x squared minus 4, because we have an exponent of 2. Could have something like a square root, like y equals square root x plus 6. That would not be linear. A square root is the same thing as a 1/2 power. So, you know, that would be x to the 1/2 power there, so that's not an exponent of 1. You can't have a variable in the denominator, so something like y equals 4 over x would not be linear. This would be the same thing as 4x to the negative first power. And so again, that would be a power that is different than 1. All right, so now that we've talked about what a linear equation looks like, we're going to look at 3 different ways to graph a linear equation or a line. First, we're going to make a T-chart. So to make a T-chart, you make a chart that kind of looks like a T, which is why it's called a T-chart. And you pick values to plug in for x, and then you will compute the corresponding y value. So let's look at this first example here, y equals 3x minus 4. I'm going to pick some values for x, like maybe 0, maybe 1, maybe I'll throw a negative number in there, -2. And then I'm going to plug these x values into the equation and see what I get for y. And then I'm going to plot those points on my graph. Now, 2 points is all you need to determine a line. So technically, I'd only have to plug in 2 x values. I would recommend maybe doing at least 3, just to make sure you didn't make a silly error and that all 3 points lie in a straight line. Okay, so plugging in 0, y equals 3 times 0 minus 4, which would be -4. Plugging in 1, 3 times 1 minus 4 would be 3 minus 4, which is -1. And then plugging in -2, 3 times -2 minus 4 is -10. Now I'm going to plot my points on my coordinate plane over here. 0, -4 is right here. 1, -1 is right here. -2, -10 is all the way down here. And it does look like my points lie in a straight line, so that's a good sign that my math is good. And then, oh goodness, hopefully you can draw straighter lines than I can. So that would be the graph of y equals 3x minus 4. Okay, let's see another one where we use a T-chart. Then we'll go on to another method to graphing linear equations. For this one, here's my T-chart. And this one, I'll probably want to pick values for x that are multiples of 3. I notice I have a denominator of 3. Now, you don't have to, but it's going to make the math easier. So maybe I'll plug in 3, 6, and negative 3. Now, you don't have to. You could plug in whatever you'd like. I'm just trying to make the math easy, and I want to get some integer answers instead of fractions. So, okay, so let's try positive 3. So 2/3 times 3 plus 2. 2/3 times 3 is 2, and 2 plus 2 is 4. So I got 4. What I did is, sorry, I cross-canceled those 3's there. That's where I got the 2 from. So that would be a 1. That would be a 1. If I plug in 6, 2/3 times 6 is 4, and 4 plus 2 is 6. So I get 6 here. Again, I cross-canceled. That's where I got my 4 from. And then finally, I'll show it over here. Y equals 2/3 times negative 3 plus 2, which would be negative 2 plus 2, which is 0. And once again, I cross-canceled here. Okay, so I'm going to plot 3, 4, right there, 6, 6, and negative 3, 0. And good news, my points do appear to lie in a straight line. And this would be the graph of that equation. Wow, that line was a little bit straighter. Okay, let's look at another method for graphing a line, and that is by finding the intercepts, the x and y intercepts. You can see up here that to find an x-intercept, we're going to let y equal 0. And to find the y-intercept, we're going to let x equal 0. I'll find the x-intercept first. The reason why that works is because all along the x-axis, the y-coordinate of every point is 0. So, this is the point 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0. So y is going to equal 0 along the x-axis. Okay, so let's see, x-intercept. So I'm going to plug in 0 for y, and 5 times 0 is 0, so I just get this, and divide by 4. So my x-intercept is 5, or as an ordered pair, that would be the point 5, 0. So here's my x-intercept. To find my y-intercept, I'm going to plug in 0 for x. 4 times 0 is 0. Don't lose that. I've got subtraction here, so don't lose that sign as a negative sign there. Divide both sides by negative 5, and y equals negative 4. So our y-intercept is negative 4. As an ordered pair, that would be the point 0, negative 4. Now, I mentioned earlier that 2 points determine a line. So we only need 2 points to graph a line. I've got my 2 points. I've got my x-intercept. I've got my y-intercept. I plot those 2 points, and there is my line. All right, let's do another one where we find the intercepts. First, let me find an x-intercept, or the x-intercept. I'm going to plug in, I'm going to plug in 0 for y. Sorry about that. I'll just cross that out. Okay, so 0 equals negative 2x plus 6. And then to solve, I'll subtract 6 from both sides of the equation. Then I'll divide both sides by -2. And I get 3 equals x, or x equals 3. So it looks like my x-intercept is 3, 0. And then to find the y-intercept, I'll plug in 0 for x. Actually, it's going to go a little bit quicker than the x-intercept. And -2 times 0 is 0, so y equals 6. And we've got the point 0, 6. All right, then I will draw a line through my 2 points. Ooh, okay, not so good on that one. And so this would be the graph of y equals -2x plus 6. There is one more method we're going to talk about, which is using slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope and 0b is the y-intercept. To graph, we're going to plot the y-intercept, and then we're going to use the idea that slope can be expressed as rise over run to find a second point on the line. Okay, so let's see this example here. So slope-intercept form is, like it said over there, y equals mx plus b. This is your y-intercept. This here, m, is your slope. So in our example, the y-intercept would be -4. As an ordered pair, that would be 0, -4. The slope of our line is 7/3, or 7/3. And I'm going to use the fact that slope is rise over run. I'm going to use that. Okay, so let's see how this works. First, you're going to plot the y-intercept, which should be here, 0, -4. Now remember, a y-intercept will be on the y-axis. Sometimes students incorrectly plot an x-intercept. That's a y-intercept, not an x-intercept. And then from that point, so not from the origin, but from that point, I'm going to use rise over run. Since the rise is positive, I'll go up. And since the run is positive, I'll go to the right. I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. And then right 3. 1, 2, 3. And I have now found a second point on my line. So I went up 7, right 3, because of my slope being 7/3. And then I'll draw my line. Make this point a little darker there. There we go. That would be the graph of y equals 7/3 x minus 4. Okay, let's look at number 6 now. This is under the slope-intercept form section. And so I need to first put this in slope-intercept form. I do want to point out that this problem, if you were asked to graph in whatever way or using whatever method you'd like, if it were me, I would find the intercepts. I would find the x and y intercepts. That would go pretty quickly, and you'd have your graph right away. Okay, but we'll use slope-intercept form, but I do want to point out that this one would be graphed the quickest using the intercepts. Okay, if we want to graph using slope-intercept form, I've got to put it in slope-intercept form. It's not in slope-intercept form. And slope-intercept form is y equals mx plus b. So basically, we've got to solve for y. First thing I'm going to do is subtract 9x from both sides of the equation. I'm trying to isolate y. Ooh, sorry, I'm going to take a drink. Okay, there. Then I want to get my term containing an x first. And I got to be careful here because subtraction is not commutative. So I can't just swap these. Addition is, however. So maybe I'll make this, instead of 18 minus negative 9x, maybe I'll write that as 18 plus a negative 9x, which is the same thing. They're equivalent. And then I can commute those two terms. So I can see I've got this. And then we'll divide both sides of the equation by 3. Same thing as dividing all terms by 3 to get y equals negative 3x plus 6. So here's our slope-intercept form. Our y-intercept is 6 as an ordered pair. That would be 0, 6. And our slope is negative 3. I'm going to write that as negative 3 over 1, just so I can talk about the rise and the run thing again. So negative 3 is equivalent to negative 3 over 1. Okay, so here's my rise. Here's my run. So I'm going to plot my y-intercept at 0, 6. And then because my rise is negative, I'm going to go down. So I'm going to go down 3, 1, 2, 3. But I'm going to go right 1 because my run is positive. And draw my line. Ooh, sorry about that. Okay. I have 2 more examples here. I just wanted to also put in this video graphing horizontal and vertical lines. And I feel like students try to memorize these, try to figure out, okay, if it's x equals, that means this, and I can't remember. So I'm just going to kind of explain how you can tell you don't have to memorize. If you want to graph x equals 4, notice that there's only one variable, x. There's no y variable. And you want to find a line along which x always equals 4. This is actually going to be a vertical line. It's going to look like this. Notice that every point on this line has an x coordinate of 4. Here's 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7. Okay, so no memorization needed. I could just find, I'm looking for a line where every point has an x coordinate of 4. So if your equation only contains the variable x, it's going to be a vertical line. This is a horizontal line down here. Oops, still can't draw my straight lines here. Notice along this line, our y coordinate is always negative 3. Here's the point 1, negative 3, 2, negative 3, 3, negative 3, 4, negative 3, 5, negative 3. So if your equation only contains the variable y, it's going to be a horizontal line. All right, well, that's it for graphing lines. Hope you found this video helpful.